Hello, this is the second video on the series of videos on multivariable calculus, Math 241 from University of Maryland. So in this video, we're going to talk about vectors and operations between vectors. A vector in three-dimensional space is an object. Usually we think about vectors as objects that have a direction and have a magnitude. Now, if you are given a vector in three dimension, how do we represent that vector? We generally think about vectors as from the origin to a point. So if you start from the origin to a point, you get a vector v that is denoted by a comma b comma c. So it's a triple of numbers, and the order of course does matter. Now we can draw vectors from other points as well, and that's something I'll talk about that in a minute. So we generally denote points by capital letters P, Q, R, and so on. And we generally denote vectors by lowercase letters, either by putting an arrow on top or making them bold. Now the magnitude or length of a vector, if you look at a vector from the origin to the point a comma b comma c, the magnitude of that is evaluated using the distance formula. So it's the square root of a squared plus b squared plus c squared. Now if you have a vector from a point p to a point q, if the point p is x1 comma y1 comma z1 and point q is x2 comma y2 comma z2, vector from P to Q is denoted by PQ with an arrow on top, and that shows the displacement from P to Q. The displacement of X would be X2 minus X1, displacement for Y would be Y2 minus Y1, and the displacement for Z would be Z2 minus Z1. So that's how we evaluate a vector from a point P to a point Q. How do we add vectors? Well, first we're going to talk about adding vectors algebraically, and then we'll talk about them geometrically. Sum and difference of two vectors. If you want to add two vectors, you add them component-wise, which means x1 and x2 are added, and we get x1 plus x2. y1 and y2 are added, and we get y1 plus y2. And finally, z1 and z2 are added, and we get z1 plus z2. So that is how we do that algebraically. Now, what does it mean to add two vectors geometrically? If you have a vector AB and a vector BC, when you add them, you get the vector from A to C. And this is called the triangle law because of the obvious reason that we get a triangle here. Now, if you have two vectors that the initial points are the same, so if you have a vector AB and a vector AC, that the initial points are the same, the way we create the sum of these two vectors is by creating a vector that is parallel to AC and it starts from B, and this gives me the sum of AB and AC. So this is the sum of AB plus AC. And as you see, we have a parallelogram. ABDC is a parallelogram here. ABDC is a parallelogram, which is why this is called the parallelogram law. Now, how do we multiply vectors? The first thing we're going to talk about is how do we multiply a vector with a scalar or a real number. So if you are given a vector v, if you double that vector, you get a vector in the same direction and its length is doubled. If you multiply that vector by a negative number, the direction is going to be changed. So this would be, let's say this is negative v, and if you multiply by something else, maybe negative like 3/2 v, you get something like that. The length becomes larger and the direction is opposite. Algebraically, you multiply each of the components by that scalar. Now, we talked about how vectors have directions and length. So we talked about the length of a vector. Now, what is a direction? A direction is basically a unit vector. So any vector that has length of 1 is called a unit vector. There are three specific unit vectors that are really useful, and we'll talk about these unit vectors all the time. These three unit vectors are the vectors in the directions of x-axis, y-axis, and z-axis. In order for them to have length of 1, they would have to be at points 1, 0, 0, 0, 1, 0, and 0, 0, 1. This one is I, this one is 1, 0, 0, This one is denoted by J, 0, 1, 0, and this one is denoted by K, 0, 0, 1. All of these are unit vectors in the directions of X, Y, and Z axis. Okay, any vector that you take, if you take a vector a comma b comma c, you can write it down as a comma 0 comma 0 plus 0 comma b comma 0 plus 0 comma 0 comma c. Basically breaking it up into three different vectors. Now the first one is going to be a times I, the second one is b times j, and the third one is c times k. So every vector can be written in the form of ai plus bj plus ck. A, b, and c are the three components of that vector. Now the benefit of that is that this is always going to be a vector. If I write down v equals ai plus bj plus ck, that is always a vector. But the one with parentheses, sometimes we refer to that by a point, sometimes it represents a vector. So this notation is in fact less ambiguous than the other notation. If you want to find the unit vector in some direction, what you do is you take that vector and then you divide by its magnitude. So let's look at an example here. Consider the points P equals 1 comma 0 comma root 3 and Q equals 3 comma 3 comma 0. We want to find the unit vector in the direction of PQ. So the first thing we're going to do is we're going to evaluate PQ. So PQ is going to be terminal minus initial. So we'll have to take 3 and subtract 1 from that. It's always terminal minus initial rather than initial minus terminal. This would be 3 minus 0 and then 0 minus root 3. So PQ would be 2 comma 3 comma negative root 3. So the next thing we're going to do is we're going to have to find the magnitude of this vector. So magnitude of PQ would be square root of, by the formula that we just talked about, 2 squared, so this coordinate squared, plus 3 squared, and then plus negative root 3 squared. So let's evaluate this. This is going to be square root of 4 plus 9 plus 3. So that is the square root of 16, which is 4. Now this is the magnitude of this vector. We want to find the unit vector in that direction. So we take the vector 2 comma 3 comma negative root 3 and we divide that by its magnitude. So the answer is 1/2, 3/4, and negative root 3 over 4. So this is the unit vector in that direction. Next, we are asked to evaluate the vector in the opposite direction of PQ whose length is 7. Well, we need the length to be 7. We know that this has length 1. So in order to make the length to be 7, we'll have to multiply that by 7. And we also we want to make sure that it is in the opposite direction. So we'll have to negate it. So we'll have to take the unit vector, negate it. So 1/2, 3/4, and negative root 3 over 7 over 4. And then we'll also need to multiply it by 7. So we have to multiply that by negative 7. So that would be negative 7 over 2, negative 21 over 4, and 7 root 3 over 4. So this would be our answer to this second part of the problem. Now if we take two vectors as we discussed, multiplying by a scalar, we get a vector in either the same direction or the opposite direction. So in any way, those two vectors are called parallel. So let's look at an example. We are trying to find two numbers x and y for which the vectors 3, 6, 2 and x, 2y, x plus 9 are parallel. So for these two vectors to be parallel, we need x comma 2y comma x plus 9 to be a scalar times 3, 6, 2. So let's see what that gives me. So on the right, we get 3r, 6r, and 2r. The three components of this must correspond to each other. So x must be 3r, 2y must be 6r, and finally x plus 9 must be 2r. So let's see what we get. We get x equals 3r, 2y equals 6r, and x plus 9 equals 2r. Now this is a system of equations. We have 3 equations and 3 variables. So what we can do is we can find x and y from the first and second one in terms of r and plug it into the last one, for example. That's one thing we could do. There are other ways of solving this one as well. So I'm going to evaluate y from here, that's 3r, and I'm going to take the first one, which is x equals 3r, plug it into the last one. That gives me 3r plus 9 equals 2r. So that gives me r plus 9 equals 0. So that means r equals negative 9. So that tells us x equals 3 times negative 9, which is negative 27, and y equals 3 times r also, which is negative 27. So the answer is x equals y equals negative 27. Okay, so far we have talked about multiplying a vector by a scalar and adding and subtracting two vectors. The next thing we're going to talk about is a form of multiplication of two vectors. There are two different types of multiplication of vectors in 3 dimensions. The first one is the dot product. The dot product of two vectors u, u1, u2, u3, and v, v1, v2, v3 is simply evaluated by multiplying the corresponding components and adding them. So u1, v1 plus u2, v2 plus u3, v3. Now there are some properties of this dot product which is useful to know, and I'm going to go over these 5 properties, and there's more properties, but these are really the main ones that we will be using. The first one is that the dot product of two vectors is a scalar, which means it's a real number. So it is not going to be a vector. When you multiply two vectors, when you evaluate the dot product, you will get a real number, not a vector. The second one is we have commutativity. So when you find the dot product of u and v, you could do u dot v or v dot u. Those two are the same. Next, we have the distributive law, which means u dot v plus w is the same as u dot v plus u dot w. Next one is associativity. So if you look at c, constant c, a scalar c, you can take it out. You can do cu dot v is the same as c parentheses u dot v. Next, if you find the dot product of a vector with itself, so you would get u1 squared plus u2 squared plus u3 squared. That's the dot product of a vector u with itself. And that's obviously the same as the magnitude squared. The last one is not quite obvious, but you can get that if you have done law of cosine in high school. You can get this formula from law of cosine. And the formula tells you that if you take the dot product of two vectors, that's the same as magnitude of one times magnitude of the other times cosine of the angle in between. So let's do one example on this one. Find the angle between the vector I plus 2j minus 2k and the negative x-axis. So I'm given one vector and then I'm given negative x-axis. First, I'll have to find the second vector. So negative x-axis, what is a vector in the direction of negative x-axis? So negative x-axis means negative I. So x-axis means I, and negative x-axis would be negative I. So negative I would be in the opposite direction of the positive x-axis. So what we need to do is we need to look at I plus 2j minus 2k. Find the dot product of this with negative I. So let's evaluate this. This is going to be, if you multiply that, we get 1 times negative 1 plus 2 times 0. So 1 is the coefficient here, and negative 1 is the coefficient here. 2 is the coefficient of j here, and there is no coefficient of j here, so that's just 0. And then plus negative 2 times 0. Evaluating that, we get negative 1. So this is negative 1. Now, on the other hand, dot product is also the same as magnitude of the first vector times magnitude of the second vector times cosine of the angle in between. So let's evaluate magnitude of this. Magnitude of this is the square root of 1 squared plus 2 squared plus negative 2 squared. And then this one is square root of negative 1 squared, and then cosine of theta. Now these two quantities must be the same thing because both of them are dot product. So we get -1 equals square root of 1 plus 4 plus 4. -1 squared is 1, and then we get cosine of theta. So cosine of theta is equal to -1 over 4 plus 4 plus 1 is 9. Root 9 is 3, so we get -1/3. So that means the angle between these two vectors is cosine inverse of -1/3. In general, to find the angle between two vectors u and v, we could use this formula because we know that u dot v is magnitude of u times magnitude of v times cosine of theta. So solving for theta, we get the angle. So to summarize, what we did in this video is that we talked about how to find the vector between 2 points. You should subtract the initial from the terminal. The dot product is evaluated by multiplying the corresponding components and then adding them up. And then the formula u dot v equals magnitude of u, magnitude of v, cosine of theta is used to find the angle between two vectors. I will see you in the next video.